Hi all, I am Tejeshwar. I am working as a junior data analyst trainee in Data, and this is my next task, ATM Fraud Detection. So for this we require this much libraries. These are the basic libraries. We are going to import all other necessary libraries in oncoming. Okay. So this NumPy is for any mathematical calculations, and Pandas is for data processing, and Seaborn is for visualizations. So you want to download all these data sets. Okay, Geoscores, Lambda, QSet, Instant, Train, and Test. So these are the data set. I have loaded all these data sets here. So just I'm going to run these cells. Okay. Yeah. So you want to run these cells using this pd.readcsv. This read CSV is a function inside this pandas. Okay. So just paste your dataset path here to run in the CSV file, and these are the train data head. So by using this train data, you can call your dataset, and this head function just gives you the top 5 of your dataset. Okay. So these are the top 5 rows of your dataset. ID, group, and per one means like person 1, person 2, person 3, and credit 1, credit 2, credit 3, and normalize, and this is the target we are going to find, right? So these are the things. And also for test, these are the things we have: a same ID, group, per 1, per 2, and the same things. In this we don't have this target, because for test data we are going to find this target, right? So these are the things here we have. And the next is geo value counts. So we have the 6 to 7, right? 6. Okay. So we have around 6 data sets. So we already seen this 2 data set, and the third is geo, fourth is lambda, fifth is qset, sixth is instance. So this geo, lambda, qset, instance, or just one have only one row, one column, which means geo score and lambda and qset and instance. So these are the scores for finding if there is any fraud or any ATM machines. Okay. So I'm just going to count the values. So these are the value counts, and I'm going to print the top 5 of the value counts. So these are the top 5 of the value counts in geoscore. These are the top 5 values in this lambda, and these are the top 5 in the qset normalized, and these are the top 5 in the instance scores. If you didn't put this head, the output will come, but it come for all the instances. Okay. So these are the thing we have, and we want to check the null values. So just check for all this data set. So in geo dataset we have around 71,000 columns, 71,000 rows has null values. In lambda there is no null values, and in instance there is no null values. In qset we don't have any null values. To find this null values, we already know we are going to use this isNull function, and to add all these values we are just going to use this sum. So yeah, in this qset we have around 1,03,201 null values. So we want to replace or fill with those things. Before that, we are just going to put a plot, which means a box plot, by using SNS Seaborn library. X variable as a geo score, which we have, and data is a geo data set, and orient equal to h, which means horizontally we are going to plot it. So you can able to see here. Yeah, so it is in horizontal format, and these are the things we are going to have. Like this 0 is the median, this is the first quartile, minimum, first quartile, this is the median, and the above is third quartile, and the another line is maximum. So this is the thing we have. And same as for geo scores, we are just going for qset normalized also, the same code. Okay. So for this also we have around this same nearby same box plots. Okay. So yeah, and now we want to fill this null values. Okay. So to fill this null value for geo score, I'm just calling the geoscore column, and to fill this NA, I'm just going to use this fill NA, and I'm just going to calculate the median. For the values in the geoscore, I'm going to find the median, and I'm going to fill the median value into the missing values. Okay. So yeah, I'm going to fill the missing values with by replacing it with medians. So as same as for Q set also, we have seen around 1 lakh data set, 1 lakh null values. So I'm just changing, I'm just going to fill with its median. So again, after fill those things, I'm just going to check is there any null values. There is no null values present for Geo and Q set. Yeah, so there is no null values present. Now I'm just going to find the mean of the IDs. So what is the mean of the ID? And now I'm just going to print those things. So these are the geo scores for the mean of IDs. Okay, so it's just for simplicity. As same as for Q set and as same as for instance, I'm just going to do the same. Okay, now leave those things. Now we are just going to split our data into train and test, right? So we are just going to replace this train data with the train and test of data with the test. So now we can see the train data of head, which is like ID group and yeah, it comes left, which means we in this train data, I'm just going to create a column data with all the values as train, and for test you can see that's yeah, for test the same thing, but it comes all as test, right? So this is the thing, and I'm just going to check any null values for training data. There is no null values, and also for test data, let's check. Yeah, so there is no null values. Now I'm just going to concatenate in the sense I'm going to merge the two data set, which means train data and test data, which I have prepared before this thing. I'm going to merge this two data set in the format axis equal to 0, which means I'm just going to add like a row format. Like I have the same number of columns, but the row will be increases. So we'll just run those things, and this is the head. This is the tail. It takes some time. Okay, yeah. So this is the head. You can see it starts from train and it ends with test. So okay, that's the thing. And now the now the total shape sense. The total shape is around 2,84,807 rows we have in respect of 29 columns. Okay, so after this, we also have some other columns, right? Like geo and instance. So you also want to insert those columns. So how to merge those things? To merge two different data sets, use this pd.merge. So this merge is a function to merge two data sets. The first all data is the first data you are going to use, and this is the data you are going to add in this all data. So this is the data you are going to add here on the basis of ID. Okay, so this ID will be the primary key, and how you are going to add in the sense, I'm going to add it in the left side of the columns. So as same as for instance, I'm going to add, and as same as for Q set, and also for what's this lambda. Okay, so after seeing this, just run this head function to see how it has been merged. So now you can see after this data, you're going to see like geo scores, instance score, Q set, and lambda. So we provide all those things, right? So this is the thing, and the basic info function to get the basic details. And is there any null values presented? There is no null values, only our target variable is in the null values. So it's not a problem. The 0 is taken as a null value, so it's not a problem. So just leave those things. And yeah, this is the train data, and I'm going to fill in the test data. This is the train data dot head for displaying the train data. Okay, so this is the thing. Now we are just going to prepare a model to train, right? So to train, we want to provide our data set. So in this data set, I'm just going to remove this ID group because these are the unnecessary things. I'm going to remove this ID group, and the target is the variable, target is the output variable. So we want to remove it from the training data set and the data. So we are just going to remove all those things in the respect of axis equal to 1, which means column wise I'm going to remove, and the y, which is the predicting variable, is target. So we are going to predict this target, and so what I'm using this in the y. Okay, so yeah, and just also run this, and this is the head of the x and y of head of y. So in this case you can see this target and all run got out. So this y only has this target columns. Okay, so now to feature scaling, because this x is going on from 1 0 and it going a lot of numbers, right? So in this case you can also see there are around -245 and all. So we want to scale all those things in a particular format. So we are just using this standard scaler, which scales everything in a single end to end, which means 1 to -1 or 10 to -10 in this format. So I'm just going to transform it with the for the x variable, and I'm just going to use this transformed x, which means scalar dx values. And this is the scalar dx, the same data set value. So now you can able to see everything in this sense. And this is the y is sense, not a problem. Okay, and yeah, so in this case I'm going to use this smooth, because why we are going to use smooth in the sense, here you can able to see there are 2,27,451 values of 0 is there, and only 394 of 1 is there. So our model will become overfit for 0 and underfit for 1. So to remove this imbalance or to remove this bias, we are just going to use this smooth technique. Smooth technique is used for encouraging the minority classes, which means this 394 is just multiplied and it got balanced in this data set by using this smooth. This is the work of the smooth. So just run this, and after run you can able to see the smooth shape. So 4,54,902, which is for x, and 4,54,902 for y. Okay, and now you can able to see this after smooth, the value count. So now it has been samed 2,27,451. Okay, so this overfitting will become normal in this case. So now I'm just going to split this data with using this train test split function. Just split this thing using this train test x and y with the training size of 75. I'm just going to use this train size here with this 75% of training and 25% of test, and random state equal to 101. So these are the details I have, and I'm going to create a model which is a TensorFlow. So if you're going to use a neural network, just use this TensorFlow and a Keras. So this Keras will become a better model, better for your deep learning models. Okay, sorry, deep neural networks. And I'm just going to use this Keras sequential in this case, a neural network I'm just going to create. Okay, so in this neural network I want to add the hidden layers. So I'm just going to use this add function to create a layers. The layers is a dense layer with the 50 units of neurons, and I'm going to use this activation function as a ReLU function. And as same as I'm just going to create another hidden layer, and the last layer which is an output layer with just 1 unit. Okay, which is a 1 neuron. And activation, I'm just going to use here as sigmoid function. Activation function just provides you a better output. And I'm just going to use this optimizer. Optimizer is used to change your weights according to the loss. So to calculate the loss, I'm just going to use this binary cross entropy. This binary cross entropy is used for the binary classification methods, and by using of matrix equal to accuracy. By calculating the accuracy, the loss will be calculated, and the loss will converted to the optimizer, which tells how to change the weights. And just run this. There are by using this fit function, you can able to run your data set for this training X and training Y. These are the two data sets we have for training, and epochs equal to 10. So for the 10 epochs, the work will be done, and the batch size equal to 100. So we have around 2,27,000, right? So it will take around 100 like those things for 2 lakh data sets, and it takes fully for these things. Okay, so it takes some time to run these things. Just wait for a minute. So yeah, it finished the running process. And to get the model summary, so this is the basic summary. If you created a neural network, it provide you this basic summary of your details. Okay, so and for the prediction, so in this case we are just going to calculate the accuracy. So to calculate the accuracy, we just basically predict the test variables to to see how your model is going to predict those things. And this is the thing. I'm going to use this model.predict for the X variables, and I'm going to prepare a confusion matrix, classification report, and accuracy score for those things. This is the confusion matrix. Okay, so this is the true positive, and this is the true negative, and false positive and false negative. These are the things we have, right? So these are the things it has been correctly identified, this true positive and true negative. And the classification report for this model is, yeah, so in this case you can see for false it has been precision is 1, which means 100% accuracy. For true variables, the 100% accuracy, and recall F1 score if everything is in 100% accuracy. So we can able to say our model is more better for predicting the ATM fraud detection. And also you can see the accuracy score. So the accuracy score is around 9,966. So it is around 99.9. So in this case we have arrived this 1%, which is 100% of accuracy. So yeah, I think that's the end of this thing. Okay, so okay, yeah, that's the thing. Okay, thank you.